Very much, Charles. So as you mentioned, my name is Justin Cook. I work in the Programming Environments and Models group, and today we're going to talk about programming environments and compilation on Perlmutter. There are four main ways of getting software on Perlmutter. Once you've logged in and you don't really know what to do, these are the four ways that you can kind of figure out where you're going to get your software from so that you can do your science. There's module files that you can load. You can get your software from a container by pulling it in using different options. You can compile your code from source, or you use a package manager such as Conda, Spec, or the E4S system. Modules are for pre-installed software that either Cray provides for us to provide for you, or that we provide to you as a service. For example, if we want to take a look at if you wanted to use Python, the default Python installed is a 2.7.18, and that's mainly meant for the system so that the system can do things as well with Python. But if you take a look at what module is available, you'll see that we have a Python module available for you to use that makes use of not only our expertise, but some initial bootstrapping for you as well for things like MPI-Py and Conda and things like that. There's a default set of modules that are loaded once you log in. These all target the GPU nodes by default, and they also allow you to do normal programming just on the CPU. But if you wanted to do CPU only, you would swap this GPU module at the end, number 15, to CPU. Otherwise, the major things to look at here are the CPU architecture is defined by this Cray PE86 Milan. The default program environment compiler is highlighted in red, and that's so that it shows that you're using GCC and GNU. And the GPU architecture and CUDA-aware MPI are highlighted in green. And that's so you can show that, one, you're using GPUs and what model of GPU you're using. There's several other modules in here that are important to use and important to know about, but we're not going to talk about those for now. Modules have a few common commands that are used commonly, that are used for finding, loading, and searching for software. Module list will show you what you currently have loaded and what you want was what they're doing. Module load and unload of the package will load in the software and modify your environment so that it's available for you. Unload does the opposite. Module help sometimes will give you some useful information about the package that you're trying to load. Sometimes it will not. Module show, again, will show you what the module is actually doing to your environment and should give you some information on what the module is. And module spider helps you search through what modules are available on the system through the different module installations. You can get more information by doing man module on the system and reading the man page, or by looking at our documentation at docs.nurse.gov. Module available is not necessarily useful for searching. Because Perlmutter uses a hierarchical model of module files, it's not going to display all the modules available when you use module avail. I know that sounds a little backwards. It's just the way it is. Instead, you should try and use module spider if you want to search through all possible module files. Now, some module files you shouldn't load in certain environments, and that's why module avail only shows you a certain subset because of the way your environment's set up. You wouldn't want to use, for example, the PGI compiler if you had the programming environment loaded for GCC. This is just kind of a small example. But more information, again, is in our documentation or in the man page. When I say load a module, it actually does a lot of stuff to your environment in the background so that you don't have to worry about it. What it does, for example, here in the red is a bunch of module related stuff where it sets the help and the what is, and it tells you other types of modules that you shouldn't load with this. But then it also sets a bunch of environment variables and sets a bunch of environment variable path or a bunch of paths for the different things such as loading shared libraries or getting access to binaries. Some of these are very Cray specific, and that's just part of the way Cray does their programming environment. And some of these are things that are useful for you as well, such as setting up the path or the package config path. So this is just a simple example of what it takes to compile a piece of software, starting with just your average piece of code. This could be a simple hello world or a simple communications pattern. You take your compiler, you input your code, and you get out object code, which is code.o. You then pass that to the linker where the libraries such as libloss or libmpi are linked with it, and that out of all that comes a program which is machine readable and executable by the system. Now, what you may have done on other machines isn't necessarily going to work on this system because HPE uses something called compiler wrappers, which includes all of the things in your module environment and some things that maybe you wouldn't know to include in your normal code. So if you use just regular GCC to compile your software, you might not get the MPI. And if you use MPI-CC to compile, the wrapper might not include other things that are in your environment. So the best process to follow for Perlmutter is to use the Cray approach, which is module load your programming environment that you want to use, and then use the CC compiler wrapper for your Hello World example. This is an example of a C++ code that compiles and uses MPI for communication example. And again, we have a very simple compile line down below that uses the capital C compiler wrapper to do everything rather than G++ or C++. This is an example C code that is a hybrid of using MPI and OpenMP. And you can see from the source here that it uses OpenMP around to get you the thread count, and it uses MPI to get you the rank count. So when you were to run this, it would tell you what rank and what process thread that you were using. And again, we're just making sure that we're compiling our source code and we're outputting to a executable. We're using the Cray compiler driver. And in this case, we have to define that we're using OpenMP by using the -f OpenMP flag. This is an example GPU source kind of grab that has information on using CUDA as well as MPI. And in this case, MPI is using GPU aware information. So if you wanted to compile this, you would want to make sure that you were using programming environment for NVIDIA, and you would want to make sure that you're compiling normally using the wrapper. And then if you were to run this, you need to specify the -G so that it tells how many GPUs you want to run against this as well. Now, I talked about kind of a CUDA enabled MPitch, and this is because the GPU module is loaded. The GPU module sets this environment variable mpitch GPU support enabled, and that tells the mpitch that you are working with GPUs as well, and you should be aware of them. The support is only for the mpitch when GPU is enabled. If you were to swap the GPU module for CPU, this would go away. And this is typically what we ask you to do when you want to run without GPUs. Some basic compiler settings that are good to know. For GNU, Cray, and NVIDIA, you can set the default optimization level using the -O. And for GNU Cray, it is -O0. And for NVIDIA, it's -O1. If you want something more aggressive for your optimizations, but can cause other problems, you can use -O fast. Or for NVIDIA, it uses -fast or -O4. To enable OpenMP, which is not something that's enabled by default on this system, you can use the different OpenMP flags that are described here. And for NVIDIA, they have something called GPU offload so that you can say whether or not you're using the CPU or GPU for your NVIDIA settings. There's another feature called OpenACC, which again is an OpenMP variant, which uses accelerators, and you can use that on the NVIDIA compiler and the Cray compiler using different flags. There's debug options in case you want to debug your source code using GDB or one of our many excellent visual or command line debuggers. You would want to set the -G flag, which will make sure to include symbols so that the compiler can see within to your source code. But you also want to turn off all of your optimizations because optimizations can kind of hide code that's running in there from other things. The -V is for verbose, and it should give you more information when you're doing a compilation. For more information on the different flags and different ways to run the compiler, we have several man pages available for you to look at, as well as the compiler's information on docs.nurse.gov. So next we're going to look at configuring some of these compilers and libraries. The compiler wrappers that I've been talking about here are just thin things that add extra functionality from the environment so that when you're building your source code, you don't have to add everything else manually. Now, if you were to add this cray PE verbose flag when you're doing a compilation, you can see all of the different things that's being done. For example, it's setting the correct architecture for Zen Ver 3. It's setting several definitions for Cray x86 Milan and Cray NVIDIA and Cray XT Compute Linux so that it knows what targets what it's targeting, and it can load and unload different types of optimal code. It's also setting include paths and linking up different things that could be useful for you on your default run. Again, this is more of that extra stuff that's being done. All of these include paths that are being added from your environment, all of the link paths that are being inquired from your environment, and all of the libraries that it's adding here at the end, as needed or not as needed, letting you know that if they aren't going to be used, then it's going to skip over as best it can. But there's a lot of things in the environment that you wouldn't necessarily know to add, and so it does this all for you. Now, if you were to switch from one programming environment to another, you would see that there would be a change in the type of stuff that's done in the background. For example, if you were to switch from NVIDIA to Intel, you could see that there are two completely different compilers being called, and that the options and the definitions might change depending on how it's best optimized to call the compiler. Now, for each programming environment, there are several compilers that are available, and this shows you which wrapper to use for each one. In this case, it's just CC, capital CC for C++, or FTN for Fortran. Each one has, again, their own individual compiler that it uses for each of those, and they all use the same Cray MPitch library, but each MPitch library is built differently depending upon the language, and again, whether you're using CPU or GPU. All of this information, though, is kind of documented in our compiler's base on docs.nurse.gov. This automatic linking provided by the wrappers adds in things like liblas, scalapack, and more automatically via things like libsci, which is in your environment by default. There are other Cray modules that are available, such as HEIF5 or FFTW, and if you want those added in automatically, you need to load those modules first before you do your compilation. There are several build systems that are in use. A lot of, applications use their own custom build system based on makefiles, but the two most common that we come across are called AutoTools or AutoConf and CMake. These all basically will generate make files that once they run, you could then run make and then build out your application. The key part of using these is to make sure that you pass in the Cray compiler wrappers so that whatever tool you're using knows to use these wrappers when it's building the software. So for example, in a case where you're using makefiles, in the first line here that's highlighted, you would set CC equal to which CC and CXX equal to which CC, capital C, and FC equal to which Fortran. A lot of that is common inside makefiles for defining those compilers. Or if you want to define this at the configure step, like if you would do with auto tools, autoconf, whatever, you would do it in the configure line by setting those variables. Again, we have more information on docs.nurse.gov based off our build tools information. An auto tools example here would be something like GSL. Once you download it from GNU.org, configuring is just setting the environment variables and then running make afterwards. After that, you run make install and it installs it where you need to install it. Oops. That was not what I meant to do. Sorry, I accidentally clicked the link there. Do you still see the presentation?
Yep, you're good to go. Or you're sharing
Okay,
your yeah, okay, you're good now.
okay. Um, so for example, the next one is to use CMake. And a good example of using CMake is using libxc, where again, you would define your environment variables if you need to. And then once you do your build, you create a directory and you run either CMake or CCMake or the version, the visual version to set up the configuration. And then once you're ready to do your make and install, you use CMake to do that as well. So in general, the best practices for compilation are if you're going to search for software, use module spider. If you want to search within your hierarchy, use module avail and make sure you're loading the correct modules for the program environment that you want. You want to make sure that you're using compiler wrappers for all of the program environment modules. Otherwise, you're going to miss out on a lot of the links and a lot of the includes and a lot of the definitions, and that could cause your code to fail in ways that you might not understand. If you have error messages, check the man files, man pages, and make sure to check out docs.nurse.gov. And if you have more questions or you need help, make sure to check out help.nurse.gov, file a ticket, and kind of describe your problems to us. Okay, that should be it.
Awesome. Thank you, Justin. Did we have any questions for Justin?
A couple,
And
but answered in the Q&A doc.
okay, awesome, awesome. Justin, did you want to tell everyone a little bit about what you do at Nurse? I'm sorry, I should have offered that to you before you began.
Most of what I do at NERSC right now within the programming environments group, when I'm not working with other people doing trainings and things like that, is working on our spec deployment and making sure that the programming environment that we do have and the programming environment that we're going to have for the next generation of systems is something that users not only want and is going to make them successful in their science, but actually works and is usable.
Awesome. And what's your, did you want to give a little bit about your background, how you fell into your interest and love of
Oh,
programming languages and environments?
I'm quite boring when it comes to HPC. I actually have a computer science background. I'm not a scientist or a doctor. So I just
You rock
happened to
still.
um, I went to school just for a computer science degree, but my first job was at Cray, and I worked for at Cray for 10 years in HPC, mainly in performance tools. So I have a deep background in debugging and performance tools and all of that stuff. So that's why I say Cray maybe instead of HPE. Um, and that's where I have my deep knowledge of pretty much everything HPC.
So I think you're pretty important for helping everyone get their science done. And if you normally have a problem with debugging, Justin does a lot of trainings on debugging as well. Okay, awesome. Any other questions? All right. Well, thank you again, Justin.